All right, so today we are going to be doing sinusoid constructions. What the heck? All right, well, first of all, what is a sinusoid? A sinusoidal is something that has a trig function in it. Even if it's not sine, it's still called a sinusoidal. So even if it's cosine, because isn't cosine just shifted sine? It isn't tangent just sine over cosine, which is sine over something that's related to sine. It's all about sine. So even if you're using tangent, you're still doing a sinusoidal because they're always based on sine. All right, so we're going to write an equation. Now, so what if you can write a trig equation? This is what I think is cool about this. Imagine you just had a watch and you were sitting on a desert island, okay, and you could observe, like, boy, the high tide seemed to have happened at 3 o'clock this afternoon. Okay? And then you keep an eye on your watch and you keep an eye on the water level and you're like, you know what? I think it's at low tide here at like 9 o'clock. Now it's at low tide. You can write a very accurate sine equation that can tell you, based on what time it is, whether it's going to be a high tide or a low tide or somewhere in between. So it's kind of cool that you can write this not just for tides, anything that has a high and a low and is going to go back and forth between them, you can write a sine equation for that. In fact, usually though, remember, sinusoidal doesn't mean necessarily sine. We usually use cosine. I'll show you why. All right, we had a lab called the Tide Lab, but the thing was a lot of kids couldn't really relate to it because a lot of kids have never seen the ocean. Now, some of you are like, what? I've seen the ocean twice or 3 times. But do you get that does require you being on a long trip? And some people just don't go on trips as much. And so I would wager that between the online kids and the kids in class here, that we have several kids that have never actually seen the ocean and don't really know what a tide is. I mean, they may have heard of it, but they've never experienced it. So here's one thing everybody has experienced: sunlight. We have changed this to a sunlight lab. Do you get that we have a low amount of sunlight in December, and there'll be one day in particular that'll be a lowest day where we have the least amount of sunlight. And then we have another day in June where we have a really lot of sunlight, a long day of sunlight. And that's called the Summer Solstice. You guys have heard of that, right? Okay, so we decided to change the lab to have to do with the sun, which makes some sense to me because you can all relate to it. You've all lived through a Minnesota winter where things get kind of dark and you don't have that much sunlight. And then the summers, though, are actually pretty cool. Did you know that if you lived on the equator, the sun would always rise at 6 a.m. and it would always set at 6 p.m.? I know that seems cuckoo, but every day for your entire life, if you never left the Galapagos Islands, which are pretty much right at the equator, they're actually not exactly on the equator, so therefore it's like a minute, within a minute of 6 a.m. and 6 p.m. So if you live right at the equator, which would be, for instance, in the country of Ecuador, I don't know if you've ever made that, correlation there, but yeah, that's related to the equator. It's pretty cool. Their day is very simple that way. Okay, so how about our day? We have a low amount and a high amount, and we need to know what times they happen, like what day of the year, and we can write an equation. So we'll talk more about the lab tomorrow. For today, I want to get into labeling my drawing here. Now, I want you to cross off the one for sine because why? Because we're only going to do these in cosine, and there's a reason. It has to do with the horizontal shift part, the phase shift, which is right in here. And I'll tell you that later. But for right now, I want to write out what we know about each of these things. This is called the amplitude. This is called the B term. And what's that equation that we know about the B term? Yes, Samik. All right. Yes. The period will be 2 pi over B. So in most of our problems, they don't tell us B, but they do tell us the period. They don't always say it out loud like the period is 5 minutes, but they'll tell you something like this. It takes 5 minutes to complete one revolution. That's basically saying the period's 5 minutes. All right, this is called the phase shift. And basically that's how far to the right or left the graph has been shifted compared to normal cosine. And last but not least, this is the vertical shift, which could be moving it up or down based on a certain number of minutes, or not minutes. It's whether it's been shifted up or down vertically. So in this case, that's a height. Okay, so my advice when you make these things is to make a wave that has a low spot and a high spot, another low spot, and just remind yourself it keeps going, right? So you make a wave, and if I beat only one thing into your head for this hour, it's what you need to be able to do this is a low spot and what time that'll be at, and a high spot and what time that will be at. Okay, so let's go to this Ferris wheel question and figure out. All right, you board at 10 feet off the ground. Would you agree that this height right here, the y value of it, the height of it is 10? And the highest spot, and the first time I looked at this, I thought the highest you went was 35 feet. That is not true. What is 35 feet actually? Yes?
The radius of the Ferris wheel.
Very good. So therefore that's 35, and so is that. And that makes the total distance there what?
70.
Add it to the 10, and the highest spot you have is 80. Very good. So 10's the lowest, 80's the highest. I've got my low spot, I've got my high spot. Then all that I really need after that is what time did they happen? Now you tell me, do you think that we would start at the high spot or the low spot? Well, it says that you get on, you board at the bottom. Okay, so you definitely start at the low spot. So I'm going to call that time 0. And at the high spot, is that 5 minutes later? No, it's what? How long does it take? Yeah, 2.5. 2.5 minutes to reach this high spot. So would you agree that this high spot is 2.5 comma 80? Think about that. The time is always the x value. If you haven't figured that out on graphs yet, time is always the x. 2.5 comma the height is 80. And this low spot here, that was at time 0. You were at height 10. Oh my gosh. I have my low spot and my high spot, and I'm going to label them on my graph. Now you tell me, did we come to a low spot first or a high spot first? Say it out loud. Low spot. Low spot at 0 comma what? 10. And the high spot was at what again? 2.5 comma 80. Excellent. Okay. As soon as you've got that, you have all the info you need to write your equation. You'll note that I never have to turn to the internet. I never have to use a calculator. I can do all of this in my head, which is kind of cool. I'm going to write a cosine equation. So I'm going to start with y equals, and I'm going to put an empty box in front of cosine. Just to remind me that there's an amplitude there that I haven't figured out yet, and I will, but. And then there's, after the cosine, this is the b term. And then it's x minus, and this is the phase shift. And then it's plus one last box. And that box is the vertical shift. This midline that runs right down the middle of your cosine graph, that would normally be 0. If this was a normal cosine graph, do you get that the line that runs down the middle would be at 0? But this one, the line down the middle is not at 0 because it's in the middle of 10 and 80. What line is in the middle between 10 and 80? Well, here's what you do. You want to find the number that's between 10 and 80. You want to average 10 and 80. How do you average two numbers?
Divide by the number of numbers.
Good. So we have two numbers, so I add them together and divide by 2. Add them together makes 90. 90 divided by 2?
45.
45. So the dotted line down the middle? 45. That midline runs right there. It used to be 0. I mean, that's where cosine runs, right? Back and forth across the 0 line. But it's been shifted in this case. And it makes sense. The Ferris wheel should be above ground, right? Okay. Now, pretty quickly, I can do this. Is the amplitude. The amplitude goes from the middle line up. It starts at 45, it ends at 80. And, oh wait, that's just the radius again. What is it?
35.
So 35 is the amplitude. Does that make sense to you? That's this number. 35. Question?
Wait, how do you find the amplitude though?
The amplitude arrow there, you just always go from the midline all the way to the top.
Oh, okay.
The midline was 45 because we averaged 10 and 80. And then amplitude is from the middle up. All right. So now, this, we have an equation for that. I had you write it down earlier so that you'd remember it now. Period is what? 2 pi over b. Did they ever tell me, hey, by the way, b is this? No. So then they must have told me the period. They told me that when you get on this Ferris wheel, that you would ride it from here to there. All right. And it told me how long it would take to complete it, a complete cycle. So that is the period. And it was what?
5 minutes.
So 5 minutes is the period. Everybody then solve for b. If my equation is 5 equals 2 pi over b, hey, you're the pre-calc student. You should be able to solve a simple equation for b. So go ahead and do that. This is the part where I need to take attendance. I'm going to pause for a sec. All right, needed to get that part done. And I asked you to solve for b. And I hope that you got 2 pi over 5. I'm just going to show you how I get that real quick. I just times it by b on both sides. And then the b's cancel. And then I divide by 5 on both sides. And I have 2 pi over 5. So that goes here. 2 pi over 5. Notice I didn't need a calculator for that. And it's exact. All right, next up. I remember telling you earlier that I would tell you why we always use cosine for these and not sine. It's because figuring out this shift is almost impossible when you're doing it with sine. But if I do it with cosine, it's really not that hard. Watch. Would you agree that the x x-axis and the y-axis are important in this. And the y-axis runs right through here. You know why I know that? Because the y-axis is where x equals 0, and that's the point 0, 10. Then here's the cool part. Figuring out where this is would be a pain in the butt. That's what you'd have to do if you wanted to figure out the equation for sine. But figuring out this is easy because if it's one of our two big points. All we have to know is how far over was cosine shifted. See, normal cosine peaks right here. This one peaks over there. So it's been shifted 2.5 to the right. So 2.5 goes right there. This will always be, and write this down, this is a good one. This will be the x value of the first peak. You know, there's multiple high spots. Look, this thing's going to keep having high spots over and over and over again. But it'll be the x value of the first peak. Yes?
This is just a thought I had. So, couldn't you flip the graph of regular cosine instead of shifting it to the right?
You are absolutely right. Instead of shifting it to the right, you could have flipped this graph upside down, and this spot, which was the lowest spot, would become the highest spot. You are correct. So I would have to take that on a test. But do you get that only happens if the graph happens to start with its lowest spot? You know what I mean? The only time this will ever work is if our graph starts at the ultimate low spot. And most times, it does not. Okay? Most times, it might be some random amount of time, and then all of a sudden you hit your high spot. All right, so there's my final answer. And let's talk through where each thing came from again. This was the amplitude, and that's from the midline to the top. This came from that equation, period equals 2 pi over b. You knew what the period was, 5 minutes, so you just solved that. This one was the x value of the first peak, and this is the midline. We get the midline here at the 45 from averaging the low spot and the high spot. Now that is some pretty cool real-world math. What did you need again? A low spot, a high spot, and what time they happen. So let's imagine that you are shipwrecked on a desert island. There's one guy who actually did that. He actually bought his own island and decided, I'm just going to move there and live on a deserted island. He bought it. He spent all the money he had saved up. He was this British dude. He saved up all his money, spent all of it on buying an island, and it was only like $13,500 or something. But that's all the money he had. He bought the island, and then just went and lived on it for the rest of his life. And so he did that at about age 40, and he lived to like 90. And he just lived on a deserted island for the rest of his life. People would come to interview him, and what he did is fixed up the island. He like cleaned it all up, you know, got all of the debris and stuff from the dead trees or whatever out of the way, and he cleaned it up so much that before his death, he was offered $50 million for his island in the South Pacific from a super rich dude from Saudi Arabia. And he turned him down. He said, it's my island. I want it to always be a beautiful place for everybody to share, not just... So they turned it into a park. And now the country that owned the island in the first place maintains it as like a national park. And that's kind of cool. In the end, he didn't need the money or want the money after all. So anyway, that's just my desert island story. So you could have done this equation on a desert island. So imagine for a moment, I give you two things. What do I have to give you? Let's do it tides to keep it simple. It's how high the water is, right? You're sitting there. How are you going to figure out the tide equation. What do you need to know? Come on, I told you like 3 times. What do you need to know? Yes?
You need to know like the highest it is during high tide, the lowest it is during low tide.
Yep.
And then how long it takes between each low tide of each high tide.
You need to know the lowest it is, the highest it is, and I'll change it up. This time I'm going to do the lowest number first. So let's say you start paying attention to the water level, and you just start watching based on, you stick a stick in the ocean, and you're like, yeah, the water's kind of calm, maybe it's a few waves, but it's pretty calm. And you look and say, yeah, I think it's at its lowest point right now. And let's say that is 2 hours after you start. At 2 hours, it's at its lowest point. And you call that 1 foot deep. At 2 hours, it was 1 foot deep. It's all relative, right? Now, you probably wouldn't know exactly where sea level was, but it was 1 foot above the bottom of the stick. And you keep watching it, and you keep keeping track of it, and at hour 5, it reaches the peak, the highest it'll ever be. And let's say that is 5 feet. It's 5 foot up the stick, the highest it ever gets. That's all you need. Always start with the midline. And then write y equals box cosine, and that's the amplitude. And the midline goes somewhere. So try to figure it out. I'll be quiet for a minute while you try, and I'll come show you the answer after we're done giving you some time. So somebody asked to see the low spot better. So at 2 hours, it was 1 foot. At 5 hours, it was 5 feet. Those are your low and your high. All right, did you figure out, because you average 5 and 1, add them together, divide by 2, 3 feet is your midline? Raise your hand if you figured out that 3 foot was important. Okay, good. That goes at the end. So that's 3. Seeing some hands up, that's good. Okay, next, from 3 to 5, this is called the amplitude. From the midline up. Colton Gleason, what's the amplitude? Last call for Colton. All right, Amara Johnson, do you know what the amplitude is? I'm starting to question if people that are online can even hear me. With somebody that's online, would you please say yes, I can hear you?
We can hear you.
Okay, thank you very much. Idle, would you be willing to tell me? Colton, I got your note there, thank you.
Could you repeat the question? Sorry.
Sure, amplitude. What is the amplitude? It comes from the midline to the highest.
Would it be? Sorry.
It's all right.
3?
From 3 feet to 5 feet.
Oh, from 3 feet to 5 feet, it would be 4. Or no, 1. Sorry. Or 2.
There you go.
Like,
Just keep trying. You ended with the right thing. That's good. Okay. So 2, because it's from the midline up. So from 3 to 5, so that's 2. All right, next we got to use that weird equation. Period equals 2 pi over b. They don't tell me b. They tell me the period. The period, they tell me, well, they didn't tell me exactly really nicely, but I will say it was 3 hours between my first reading and my second reading, and 3 hours would be the most common wrong answer because that's not an entire period. 3 hours gets you halfway. So did you catch on that the period was 6 hours? Because a complete cycle goes from either high to high or low to low. How many of you actually caught that and knew it was going to be 6 hours? Only a couple of you. Good job, though. There's a couple online. Okay, good. All right, so if the period is 6 hours, 6 equals 2 pi over b. I multiply both sides by b. And then I solve for b is 2 pi over 6. You can write that, but it is better to simplify it. Pi over 3. So pi over 3 goes right here. Next is the shift. And it goes in here, x minus. Now, you have to decide what the x value of the first peak is. Well, it's easy. The x and the y are both 5, so it doesn't really matter. But the x value is the 5th hour. X is time, so I take the time, and the time is the 5, and so it's a 5. Final answer, y equals 2 cosine pi over 3 times x minus 5 in quantity, and then plus 3. That is not super easy, but that is very typical of today's homework. So here's one last example, kind of most like the thing you'd have on the test. We've got some data about how much of the moon is illuminated. Do you get that 1.0 would have been 100% illuminated? Do you get that they didn't actually have data on exactly the moment that the moon was fully illuminated? But if on the 6th it was 98% and on the 9th it was 98%, do you get that probably in between those two is when it actually hit 100%? You see what I'm saying? If the 6th was 98 and the 9th was 98, somewhere in between the 6 and the 9 is probably where it hit 100%. Now, how do you figure out what's exactly between 6 and 9? Is it 7 or is it 8? It's not. It's right in between 7 and 8. So what's that? So 7.5 would have been the logical call to say on 7.5, and I know you might be like, that's the 7th day of June, or is it the 8th day of June? There's no such thing as the 7.5 day of June. Well, that's like halfway through the 7th day of June. You would have had the most moon possible at 100%. 1.0. Do you remember me telling you all you'd need was a low spot and a high spot and the time that they happened? So I suggest you always make a wave. Did we come to a low spot first or a high spot first? Yeah, it goes to almost 98% right away. That's a high spot. So it's high spot first, then a low spot. What was that high spot? Oh, on day 7.5, it would have hit 1.0. I know, we're kind of guessing there, but this is not meant to like put some man on the moon here. This is just our best guess for when we had 100% of the sun showing. And down here, that's the least amount of moon showing. I keep saying sun because our lab is about the amount of sun time, but this is about the moon. So that was 0.03 at what date? Then we have everything we need. Do you remember me saying to start with the midline? And that's going to be the average of these two. Add them together, divide by 2. This could round to 51 or 52%. I'm going to say that the midline is at about 0.52. Smeek?
So why can we assume that the least is 0.03, but we can't have the most at 0.98?
The only problem that we have with the 0.03 thing is that we can't really know for sure if it happened just before 0.03 or just after 0.03. But we can be sure on that other data point, if they're 3 days apart, Do you know how the moon works that way? Like it's not just going to stay exactly the same for 3 days. So then we know it had to have been going up to 100% at some point, right? And it couldn't have frozen at 0.98 the whole time. So it had to be going up and then coming back down. So I know that was a weird one. On your test, we will have just a simple lowest spot and a simple highest spot. We had to do something weird to figure out our high spot, and I kind of regret that, but it is an example of how the real world kind of sucks. It's messy. So, okay, so now we've got our midline. 52% of the moon is revealed at our midline, and that goes at the end. Cosine of blah, 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 plus 0.52. This part, from 52% to 1.0, which would be 48, that's our amplitude. Did anybody beat me to it and have a 0.48 in the front of their equation? Well, somebody online had it. That's awesome. All right. Then, this part right here, the period will be 2 pi over b. All right, so what is 2 pi over b? Well, it's 2 pi. Well, actually, I don't know b. I know period, so I should do that. So I know the period of this is between 7.5 and 24, but then we have to double that because that's from a high spot to a low spot. That's only half of a period. Has anybody figured that out and then doubled it yet? Did you get 33? Yes. All right, so it's 33. So 33 is the period. So then b is 2 pi over 33. And the last thing, x minus the x value. Just memorize this. The x value of the first peak. The x value of the first peak was 7.5. So it's 7.5. Boom. Really complicated equation. All from having some data. No calculator needed. That is what your lab is like. Let's talk about that. Your lab is about sunlight. What do you need? A low spot or a high spot? Well, think about it. Right now, are we closest to the low amount of sunlight for the year or closer to the high amount? What are we going to come to first? We're going to come to the high. So I'm going to make my graph like this. We're going to get to the high spot, and then we'll get to the low spot later in December. You're going to have to figure out, this is for the lab now, that, oh, it's actually on the 175th day of the year. I don't know exactly when it is, but you have to figure out what day of the year it is. And then how much sun do you get? And I think our max amount of sun is going to be like 14 hours of sunshine. And then on day like 345, like in the middle of the winter, in December, we get to our lowest amount of sun, which is, let's say, 9 hours. Then what do you do? Midline, averaging the 9 and the 14. Amplitude from the midline up to 175. And oh, vertical shift. You'll have to figure out how far to shift it over based on that 175. And it's going to be cosine, that's for sure. And the midline will go here. And this 175 will go here. And this will be period equals 2 pi over b. This one's the amplitude, which comes from there. So there's your overview of the lab. So how do you figure out what the lowest day of sunlight was and what day of the year that was? And what was the highest amount of hours of sunlight and what day of the year is it? We will show you some websites where you can look that up. All right, that's all I have for the video for today.